Correct. Read the question.
Explain different ways to induce current in a coil.
What are the different ways to induce current in a coil?
A current can be induced in a coil by moving a magnet.
By moving a magnet inside a coil. Okay. Then?
A current can be induced in a secondary coil by passing current through a primary coil.
By changing the current in the primary. Okay. Passing is not enough, because whenever there is a change in magnetic field, then only it can induce. So in the primary, it should be a varying current. If it is a constant steady current it is flowing, it won't induce the current in the secondary. So all of you write down this answer. A current can be induced in a coil by moving a magnet inside. That is one method. Another method, a current can be induced in a secondary coil by changing the current flowing through the primary coil, which is kept very close to the secondary. Read the next question.
State the principle of electric generator.
What is the statement?
Electromagnetic induction.
That is, name the principle. In exam, if you are getting a question, name the principle of electric generator, you can say electromagnetic induction. If it is state the principle of electric generator, means you have to say it is electromagnetic induction. Whenever there is a change in magnetic field associated with a conductor, it will induce a current in the conductor. Means you have to write the full statement. Okay?
Yes, sir.
Next question.
Name some sources of direct current.
Okay. Name some source of direct current, DC. What are
Battery.
the battery, then
Cell.
Cell and battery almost same only. Only a single one is called cell. If it is a combination of cell, that is called battery. Battery or cell. Then DC generator, solar cell. Question.
Which sources produce alternating current?
Which sources produce alternating current? Example. Yeah, very good. AC generator. AC generator. The next example is moving coil microphone. Moving coil microphone. Listen here, a moving coil microphone means the normal microphone, the mic that we use, the mic we are using on the stage program is a moving coil microphone. If you open a moving coil microphone, means the normal mic that we use for stage program, inside that we can see a soft diaphragm will be there, and that diaphragm is connected to a cylinder, soft and cylindrical part, and there is a insulated copper wire, a coil of insulated copper wire, and this is called voice coil, and these two ends of this copper wire will be coming outside as the cable of that microphone, and there will be a strong magnetic field provided by a circular magnet here with the north pole and south pole. A strong magnetic field will be provided with the circular magnet, north and south pole, and this entire thing will be kept inside a casing. And when a person is talking here, so what happens when this vibrations, sound vibrations, when the sound vibrations reaches inside, the diaphragm will start vibrating. When the diaphragm vibrates, the voice coil also will vibrate between the magnets. What happens that time? When the coil is vibrating between two magnets, a current will be induced according to Faraday's law. When the voice coil vibrates between two magnets, between the north and south pole, if the coil is vibrating in a magnetic field, it will induce a current, and that induced current depends upon the speed of vibration. And the speed of vibration depends upon the frequency of the person. So those who are talking here or singing a song here, depending on the frequency of the voice, from the diaphragm will be vibrating, and the voice coil also will be vibrating along with that. So according to the rhythm, the frequency of the person, a current will be induced. That current will be an AC alternating current. It will be flowing in two directions with increasing and decreasing magnitude depending on the voice level. And this current is passed through the wire, and it is given to the amplifier. This is given to amplifier, and amplifying, strengthening the signal. Further, it will be given to the loudspeaker for producing the same sound once again with a louder voice. So right now the mic we are using, even in front of me there is a mic, okay, it is connected to the computer system. First the mic is converting my sound into electrical signal like this, alternating current. That alternating current is further converted to electromagnetic waves, and that is transmitted and reaching your home, and you are hearing my voice. So in between us, my sound is actually a mechanical wave. That mechanical wave is converted into electromagnetic wave with the help of mic. The mic is the first component which convert a mechanical sound into electrical signal. So we can consider mic as a small generator. The mic is a small generator. It produces alternating current by using your sound. The sound vibration is converted into electrical signal. The next question, question number 4.
A rectangular coil of copper wires is rotated in a magnetic field. The direction of the induced current changes once in each
Answer is?
half revolution.
Each half revolution. We have seen in the case of the working of the generator. The first half revolution, the first half rotation, the current is flowing towards right, the next half rotation will be flowing towards left. And we know that in India AC is produced with a frequency of 50 Hertz. 50 Hertz means the coil will be rotating 50 times in 1 second, so that the current direction will be changing 100 times, because in each half rotation current direction will reverse. So if 50 Hertz is the frequency, 100 times direction will change, because each half revolution direction of current will change. So answer is C.
Name 2 safety measures commonly used in electric circuits and appliances.
Yeah. Answer. Name 2 safety measures commonly used in electrical circuits and appliances.
Earth wire.
Yeah.
Electric fuse.
Very good. Electric fuse and earth wire. Answer is electric fuse and earth wire. The next question.
An electric oven of 2 kilowatt power rating. Its power rating is operated in a domestic electric circuit 220 volt that has current rating of 5 ampere. What result do you expect? Explain.
Okay, so here the current rating means, what is the meaning of current rating? Current rating means what? It is the maximum current allowed in a branch. Here the current rating I is given, I is equal to 5 ampere. This is the maximum allowed current. And the device is having power, P is equal to 2 kilowatt is the power. 2 kilowatt means 2000 watts. And it is designed to operate in 220 volt line. Means potential difference given is 220 volt. Which equation of power should be used here? P is equal to, we need to find out the current flowing in the circuit when we switch on this oven. When we switch on this oven, how much current will be flowing through the circuit?
VI.
Yeah, power P is equal to VI. So in this equation, we need to find the current flowing through the oven when it is switched on. That is I is equal to P by V, power by voltage. That is equal to 2000 by 220. 2000 is the power, 2000 watts is the power, divided by 220 volt. It is working in 220 volt. 9.09 ampere. Means in this branch of the circuit, maximum allowed current is 5 ampere. Maximum allowed current is 5 ampere. But when we switch on the oven, current flowing will be 9.09 ampere. That means it is more than the current rating of the circuit. If the current is flowing more than the current rating of the circuit, the fuse wire will burn and the circuit will switch off. If it is circuit breaker, it will switch off the circuit. After getting this answer 9.09 ampere, you must write one sentence. Since the current flowing is more than the current rating of the circuit, the fuse wire will melt and break the circuit. The last question in this page.
What precautions should be taken to avoid the overloading of domestic electric circuits?
The first point is that there should not be any chance for live wire and neutral wire to come into direct contact. If there is any wire hanging freely, we should cover it with insulation tape. Okay, there should not be any chance for live wire and neutral wire to come in direct contact. If live wire and neutral wire are coming to direct contact, what will happen? I is equal to V by R. Current I is equal to V by R. If resistance is very small, if there is direct contact, resistance will be very small. So current will increase to very high value. That is called overloading, short circuiting. The second point, we should not connect too many appliances in the same line. We should not connect too many appliances in the same line, so that the power exceed the power rating of the circuit. So always we should connect devices which are having power always less than the power rating of the circuit. So the total current flowing in the circuit should be less than the current rating of the circuit. In second point you have to write, we should not connect too many appliances in the same line, same branch, so that the power exceeds the power rating of the circuit. So there should not be any chance for power to exceed the power rating of the circuit.